So if I throw a rock straight up with a speed of 35 meters per second, how high up will it be after 3 seconds? That's right. The time of 3 seconds is one thing that's given to us there. What are the other givens?
Gonna be a free fall?
It is in free fall, absolutely. So if it's in free fall, what do we know for sure? What quantity is the given if we know it's in free fall?
The acceleration.
The acceleration, right? Everything in free fall accelerates at the same rate.
Yeah.
Negative 9.8 meters per second squared. So we've got a time, we've got an acceleration, and what's the other given that we have here?
We got the initial velocity.
Right, the initial velocity. Thanks, Jose. What's the initial velocity going to be?
35 meters per second.
Right, 35 meters per second. Right, and that is going to be a positive velocity, right? Because we throw it upwards, right? So it's moving upwards. That's why we use a positive velocity. Okay, so we've got the givens. What's the unknown here?
Distance?
Yeah, the distance, right? How high up will be? How far upwards has it gone? So we're looking for the distance or the displacement, and that's going to be our delta y. Y instead of x, right? Because we're talking about vertical motion today. Okay, so we've got our givens, we've got our unknown. Now we just need to pick our equation, right? Which kinematics equation would I want to use if I've got time, acceleration, initial velocity, and displacement as my quantities? Only one of those has those four.
The third one.
Yeah, the third one, right? The third one doesn't have the final velocity in it, right? It's got the time, the acceleration, the initial velocity, and the displacement, just like what we have in our givens. So I'll copy down the third equation. I'll use y's instead of x's. Delta y is initial velocity times time, plus 1/2 acceleration times delta t squared. Right, and we don't need to rearrange this today, right? Because we're looking for delta y, and delta y is already by itself there on one side. So that's nice. We can just go ahead and plug in our numbers. Now remember, a lot of times the initial velocity is 0 when we cross that piece out, but today initial velocity is not 0, right? It's 35 meters per second. So we don't want to accidentally forget to do that part of it. So we've got 35 meters per second times the time, which is 3 seconds. Then we have plus 1/2 times our acceleration. That's a negative. The negative is going to be important there. You'll get the wrong answer if you forget it. Times our time squared. So times 3 seconds squared. All right, and you could put that all into the calculator at once, but I'll break that up into the two different terms. The first one, 35 times 3, gives us 105. And that's meters, because the seconds cancel out there. And then the second term, we do 1/2 times negative 9.8 times 3 squared. And I get negative 44.1. And that's meters as well, right? Because I've got seconds squared there, cancels out with seconds squared there. So I put those together and do 105 minus 44.1. And I get my answer is 60.9 meters. Right, and meters is a distance, so the units worked out to what I expected. And 60 meters, if you throw something up in the air 3 seconds later, that sounds pretty reasonable. That's pretty high up, but that sounds okay. So does anybody